many times we have found n, and like that only you have also found this n. So do practice these all the simple questions from your exercise. I'll be taking tricky questions in the next class from this sum of the n terms of an EP. Okay. Anyone having any confusion in any concept? Aisha, Ziana, Maha?
No, ma'am.
No, ma'am.
Okay, then I'm keeping it this much. Let's continue it in the next class. And yeah, in the next class, we'll be taking some like few good questions. These type of question where you have to find n, where you have to find directly the sum of n terms, you will be able to do, which is completely formula based. Okay, so we will be doing questions. I'll check from different question from NCRT also and from previous year also. Okay. Okay, then keeping it this much, let's continue the same in the next class. Today, no assessment. Homework I will send you. And yeah, take care of yourself. Thank you. Have you understood the process of like how exactly we got the formula?
Ma'am.
Yeah.
What's the next lesson you're going to start out of this?
What you said?
Which chapter are you going to start after arithmetic progression?
I will ask from the students at first, what will be your preference? Is there any preference? You can let me know, Maha.
Triangles.
Triangles. Okay. Okay, then after this one, I'll be starting triangles. We are almost, we are doing the sum of n terms. So we will take few class and we'll be done with that. Then yeah, after that, I can start triangles.
Okay, ma'am. Thank you.
Yeah, okay. Thank you so much.
Thank you, ma'am.
Thank you, everyone. Yeah, take care of yourself. Thank you. Bye. Yes, Saad, Anam, Samya, please wait for a few minutes. Let other student also join. I'm starting.
Good evening. Good evening.
Okay.
Yes, good evening, everyone. Good evening. Yeah, let's start the discussion. So we were discussing parallel lines. Let's continue with that. Before that, let me give you one question. Try solving it. Okay. The question is, prove that the bisectors of vertically opposite angle are in the same straight line. Do it. First try it. Anam, Arhan, Hanan, Saad, Heather, Mohammad Rafi, Samia, Sara. Please try it at first, then we'll be discussing what will be the possible approach for this one. Okay? Prove it
Okay.
that the bisector of vertically opposite angle are in the same straight line. We have to prove that. Are you able to do it? Try it. Then only we will be discussing. First try all possible way. Whatever is coming in your mind, try it. Then we'll be discussing. Because this question is not different. The vertically opposite angle is known to you. You understand the meaning of bisector. You understand how to prove anything as a straight line. You will be able to do it. Try it first. Are you able to do it? Anyone who has done? Raise your hand if you have done. Anyone? Yes? Anam, Arhan, Hanan, Heather, Saad, Mohammad Rafi, Sarah, have you done that? No? Let's do it. We have to prove that bisector of vertically opposite angle. Okay, so suppose we are having two lines intersecting each other like this. Okay, suppose this one is one of the angle, this one is one of the angle. We know that these two are vertically opposite angle, right? We also know that this one and this one is vertically opposite angle. So bisector of either this orange angles or maybe bisector of green angle, it's lying on the same straight line. That's what we have to prove over here. Okay, what we have to prove, suppose I am drawing a bisector of this orange angle. Bisector of this orange angle, let's say this purple line is bisecting. This purple line is bisecting this orange, the complete angle. Let me name it. Suppose we were having PQ and suppose we were having AB. Here AB, O you can say AOB. Okay, and POQ, these two lines we are having intersecting each other at a point O. Now O, let's say OM is the bisector. OM is the bisector of angle POA. Okay, angle POA, that angle is getting bisected by OM. That means this part and this part is same, right? Similarly, one more bisector I will be drawing over here. Let me draw. We need to understand the question at first and then we will start the proof. So this is the another line that is bisecting the other angle, that is angle BOQ. Okay, the black line is bisecting BOQ. Okay, and what we have to show? We have to show that this bisector OM and ON, these two are a part of same line or these two are lying on the same line. We have to show that OM and ON are lying on same straight line, or OM and ON are creating a straight line. That's what we have to show. Now first let me know whether the question is clear or not. Read it carefully. The bisector of vertically opposite angle. Vertically opposite angle is POA and BOQ. Okay, POA and BOQ are vertically opposite angle. We have to show that the bisector of these two angles. Bisector means the line which is bisecting. The line which is bisecting the upper angle and the line which is bisecting the downward angle. These two lines are creating a straight line. That's what we have to prove. Are you getting it?
Yes, ma'am.
The question is clear to everyone? Is it clear?
Yes, ma'am.
Saad, Samia, Arhan,
Yes, ma'am.
Heather, Mohammad Rafi, Sarah. Is it
Yes,
clear
ma'am.
what exactly the question says? No? Okay, let me explain. The question says that the bisectors, okay, bisector means the line which is bisecting the vertically opposite angle. The upper one vertically opposite, like here we are having two pair of vertically opposite angle. Okay. So the pair of vertically opposite angle are angle POA is equals to angle BOQ. It's a vertically opposite angle. Why? Because we have taken line AB and PQ intersecting each other at O. Okay. So POA and BOQ, these are the two angle which will be same. We understand that it's a pair of vertically opposite angle. Similarly, angle POB will be equals to angle AOQ, pair of vertically opposite angle. Now we have to show just one. Okay, one of the pair of vertically opposite angle is getting bisected, and the line which is bisecting, the pair of vertically opposite angle are in the same straight line, means it's creating a straight line. That's what we have to show over here. We are having two lines intersecting each other. Now maybe this is a pair of vertically opposite angle. This angle is getting bisected by a line. This angle is also getting bisected by a line. We have to show that this is a straight line, or it's a part of the same straight line, or it's lying on the same straight line. That's what we have to show. It's a straight line. That's what we have to show. Getting it?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
The question is clear to everyone? Now let's
Yes,
see how exactly either this figure or this figure. Any way you can draw it, any way you can take it. Okay. One of the pair of vertically opposite angle, you have to show that you are taking a bisector of that, and you have to show that both the bisector are creating a straight line or are lying on the same straight line. Okay. So either this figure or maybe this figure, whatever feels comfortable to you, take it. Let's take this one only. And what we can say, we know that POA is equals to BOQ. It's a pair of vertically opposite angle. Now, since OM is the bisector, suppose OM is the bisector, this part and this part will be same. Yes or no?
Yes, ma'am.
Yes, ma'am.
Okay. Similarly,
Yes, ma'am.
we know that ON is a bisector of BOQ. So obviously this part and this part will be same. Yes or no?
Yes, ma'am.
Okay.
Yes,
So let's
Yes,
name it properly. Let me draw the figure one more time. If the question is clear, let's try proving it. Pair of two lines we are having. Name is AB and the other is PQ. Here we are having intersection O. Now let's say this angle and this angle. This angle is getting bisected. Angle AOQ is getting bisected by a straight line OM. Okay, a bisector is there. So let's say this is angle 1 and this is angle 2. We know that angle 1 is equals to angle 2. Why? Because OM is the bisector. Now, we also know that there is one more bisector. This is, let's say, angle 3 and this is angle 4. We know that angle 3 will also be equals to angle 4 because there is a bisector. ON is a bisector. ON is bisector. You have to write it clearly. Not only bisector, bisector of angle POB. And that is bisector of angle AOQ. Okay, this much we already know. This much already given in the question that bisector of vertically opposite angle is there. Okay. Now we can take it like this. Let's take this one as angle 5 and this one as angle 6. Okay. We also know that angle 5 is equals to angle 6, vertically opposite angle. Okay. Now, if we will add all of them, it will be a complete angle. Yes or no?
Yes, ma'am.
Yes. Let's add all of them. Angle 1 plus angle 2 plus angle, let's say write 3, then 4, then 5, then 6. Anyway, you can write it according to the sequence of the figure or here and there. Doesn't matter. Basically, all the angle combined together, total will be 360 degree because it's a complete angle. It's creating one revolution. Any confusion so far? Any
No, ma'am.
confusion? Anyone having any confusion?
No,
No? Let's continue. So angle 1, basically if we will be able to show, that this 1 plus 5 plus 3, this all together is 180 degree. That means OMN, it's a straight line, like MON is a straight line, right? Or maybe if we will be able to show that the other part, angle 2 plus angle 6 plus angle 4, that is 180 degree. 2 plus 6 plus 4. 2 plus 6 plus 4. If we will be able to show that this is 180 degree, that means MON is a straight line. Yes or no? Getting it?
Yes, ma'am.
yes, ma'am.
So either we will show that 1 plus 5 plus 3 is 180, or maybe we will show 2 plus 6 plus 4 is 180. By substituting over here, recall that one time we have done one of the question where WU XY was given and we were replacing by taking the complete angle. Similarly, here also we have to do it. Okay. So let's take it. Angle 1. Let's focus on making 1, 5, 3. So 1 we will keep as it is. 1 we will keep as it is. Okay. 2 we will try replacing. So we know that 2 and 1 are same. From equation number 1, we know that 1 and 2 are same. So at the place of 2, can we write 1? Can we? Can we write 1?
Yes, ma'am.
Now 3 we will be taking because that's what we want to create. 1, 3, 5, 4. At the place of 4, can we write 3 from equation number 2?
Yes, ma'am.
Check it. 4. At the place of 4, can we write 3? Now we will replace it like this. 5 we will write as it is. 6 will be, angle 6 will be, again angle 5 we can take at the place of 6. So this is also angle 5. That is 360 degree. Okay. So 1 plus 1, 2 times angle 1. 3 plus 3, 2 times angle 3. 5 plus 5, 2 times angle 5. That is 360 degree. So we are able to show that 1 plus 3 plus 5 is equals to 360 by 2. That means 180 degree. And hence we can say that MON is a straight line. Yes or no?
Yes, ma'am.
Are you understanding the steps which we are performing over here?
Yes, ma'am.
Okay. So this is what the question says, and this is how we will approach this question. Anyone having any confusion? Have you noted it down? The question and the solution?
Yes.
Samya, Saad, Arhan,
Yes,
Heather,
ma'am.
Sarah.
Yes.
Getting it?
Yes. Yes, ma'am.
Okay. Have you noted it down?
Yes.
Just let's do the next question. Everyone, have you noted it?
Yes.
Just a second. Okay. So you already understand how to identify a ray. You already understand how to identify line segment, right? Okay. What is the definition? How to identify line segment, that you already understand. We started this chapter with the same concept. What is ray? What is line segment? Now, what is the intersecting lines? If we are having two lines which is just intersecting at a point, just getting cutted at a point, that's called point of intersection. Okay. Now suppose we are having one more line. Suppose we are having one more line which is passing through the same point of intersection. Now these three lines are called concurrent lines. Concurrent lines. Okay. If more than two lines we are having passing through a same point, that's called concurrent line. Okay. And this point is called point of concurrency. Okay. These are just terminology which you need to know. Now, one more concept is there, collinear. Collinear points. That means points which are lying on the same straight line. Listen to me carefully. Points which are lying on the same straight line are called collinear points. Getting it?
Yes, ma'am.
Okay.
Yes.
Now let's start the discussion of the parallel line and the concept related to that. Last day I have sent one homework. Have you done that? We were having this figure. This is 130 degree. This is 4x. This is 6x. So the question says find the value of x. Find, do it, find the value of x. Let me write the instruction. In the given figure, in which AB and CD are parallel. Find the value of x. Try it. Then we'll be discussing it over here. Yes, please try it at first, then we will be discussing it over here. Yes, Samya, Saad, Heather, Arhan, are you trying it? Sarah?
Yes.
Yes, sir.
Yes, try it at first, then we'll be discussing. Are you able? Anyone? Are you able to do it? Yes or no?
No.
Let's do it. Okay. Or let me add one hint over here. We can do in mathematics when we are working with this type of problem, the shapes and lines, parallel line, or maybe in triangle chapter also, in quadrilateral, whenever we will be having so many shapes, there we are allowed to do a certain construction by ourselves. Okay, we are completely allowed to introduce, like to construct anything by ourselves. If like what we will be able to do one construction, and that will help us to find the value of x which we are supposed to find over here. Construction by ourselves, is it allowed? Yes, that is completely acceptable over here. Yes, one construction or maybe more than one also construction is allowed. Okay, so what we will do, we will construct over here. What? These two here, AB and CD are parallel, but which one is the transversal we are not getting. So how we will apply the concept which we have learned so far, corresponding in alternate interior angle on the same side, extra alternate exterior, these concept whatever we have learned so far, how we will apply even over here when we are not having transversal, because transversal is also a straight line. Here CE and AE, these two are transversal, we cannot see. Okay, so what we will do over here, we will do a construction from here. A line we are going to draw from E, that is EF, we can name it. EF we have drawn over here, which is parallel to CD. We have done a construction by ourselves. EF, that is parallel to CD. EF, we have constructed a line parallel to CD. And since AB and CD are parallel, so eventually all these three lines will be parallel with each other. Yes or no?
Yes, ma'am.
Yes.
Okay. Because one theorem we have already learned, lines which are parallel to the same line are parallel with each other. So this we understand. EF when we are drawing, and that is parallel to CD, and CD is already parallel to AB. So CD, EF, AB all will be parallel with each other. Okay, so we understand that EF, AB, CD all are just parallel with each other. Now find the value of x. Now you will be able to find. Check it. you able to do it? Let's do it. Okay. So we have constructed construction. We are going to do let EF parallel to CD. Or let's write it is in a clear way, that is, let's draw a straight line EF point E, that is EF, so that EF is parallel to CD. Hence we know that EF is parallel to AB, is parallel to CD. All three are parallel with each other. Here write the theorem that you know already. Now if you will focus on CD and EF, let me highlight it. EF and CD. Are you getting anything from here? 4x. If this is 4x, can we say this much will also be 4x? Can we? Can we?
Yes.
Corresponding angles.
Yeah.
Corresponding angles.
Corresponding angle. And this CE is working like a transversal. So we have to write it. That CD is parallel to EF. CE is a transversal. And hence angle CEF will also be 4x corresponding angle. Okay. If this is 4x, then the remaining one will be 130 minus 4x. Yes or no?
Yes, ma'am.
Yes or no?
Yes, ma'am.
Total is 130. Then if you are saying the upward portion is 4x due to the parallel line concept, then the remaining will be 130 minus 4x. Yes or no? Everyone getting it?
Yes, ma'am.
And if you are getting it, then you will be able to analyze that now we also know that this one is parallel to this one. So this angle and this angle is again, tell me, both the green angles are
Corresponding.
again corresponding angle. Check it. There are two parallel lines. This one is the transversal on the downward side. On the downward side, at the same place, both the angles are there. Yeah, pair of corresponding angle. And now we can do the comparison that 130 minus 4x will be equals to 6x. Do it. 130 minus 4x will be equals to 6x. Is it possible to find the value of x? Is it possible?
Yes, ma'am.
Yes,
What
ma'am.
you got as
Yes,
x?
ma'am.
What you got?
13 degree.
13 degree. First, let me know whether the concept is clear or not.
Yes, ma'am.
Is it clear? Heather,
Yes, ma'am.
Arhan,
Yes, ma'am.
is it clear, Arhan?
Yes, ma'am.
Hanan,
Yes, ma'am.
Samia, you have already responded. Sarah. Yes, it is clear to everyone. Anyone having any doubt? First, we are doing the construction and then we are using the concept of parallel line. CD is parallel to EF. So that is 4x. This will also be 4x corresponding angle pair we are getting. Okay, CE is working like a transversal. Now again we are getting one more pair of parallel line. Again we will be taking the pair of corresponding angle and we will compare it and hence we will be getting the x value which we have to find over here. Is it clear?
Yes, ma'am.
Yes,
Okay, have you noted it down, the question and the solution you will be able to do, right?
Yes.
Okay, then I'm keeping it this much. See, the questions